Hey everyone, this is Varun from Avitalisha Vidyapeetham Amaravati campus. Welcome back. Today we are diving into a very useful topic in data structures, immutable sets and maps. And let's get started. Now, you might wonder, why focus on immutability? Well, immutability is super important when we want data structures that can be changed after they're created. This is useful in multi-threaded environments and helps prevent accidental changes in our data, which can be a lifesaver. So let's get started by exploring what immutable sets are, their key operations, and how they are different from regular sets. Now, diving into immutable sets, concepts, and operations. Let's start with immutable sets. In simpler terms, an immutable set is just a set that cannot be modified after it's created. Unlike regular sets, where you can add or remove elements, an immutable set is fixed in stone once it's created. Now, let's getting into the explanation of concepts. An immutable set is particularly useful when we don't want changes to happen to our set of values after defining it. Imagine a situation where you have a group of data that needs to be shared across multiple threads in a multi-threaded application. If the data is constantly changing, it might cause unexpected issues or bugs. Why do we use it? By using an immutable set, we ensure that the data remains constant, which makes it safer for these applications. Take an analogy and get get to know this deeper. Imagine you have a photo album with a collection of photos from a specific event, like a birthday party. Once you have printed these photos and pasted them in an album, you have decided that this album will only contain photos from the event. You can look at the photos, share the album with friends, or even copy some pictures if you want to use them elsewhere. However, you can't add new photos or remove any from the specific album. So, similarly, an immutable set is a collection that you can view or reference, but you can't add or remove items once it created. Here's a detailed breakdown of this Java code that demonstrates the creation and usage of an immutable set. Importing required classes. That includes collections. Collections, the utility class provides several static methods including unmodifiable set which we use to make a set immutable. Hash set. A hash set is a type of set that in Java that allows us to create a mutable collection of unique elements. And set. The set interface represents a collection that does not allow duplicate elements. And coming on to the main method, public class immutable set example. And moving on to the creating a mutable set that involves we create a mutable hash set called mutable set. Mutable hash set it, and we add three integers 1, 2, 3 to mutable set using the add method. Because hash set is mutable, we can freely add or remove elements. Now creating an immutable set using collections dot unmodifiable with attribute of mutable set, we create an immutable version of mutable set. The resulting immutable set cannot be modified, attempting to add, remove, or update elements in immutable set, being throw an unsupported operation exception. Also, immutable set cannot be modified. If mutable set is changed afterward, immutable set will reflect those changes because it references immutable set for true immutability. A deep copy of the set should be made before applying unmodifiable set. Now printing both sets. This code prints the contents of both mutable set and immutable set. Since mutable set is a way of mutable set, they display the same values 1, 2, and 3. Now attempting to modify in immutable set as we commented. This line commented out because it would throw an unsupported operation exception if attempting to modify immutable set is not allowed and would result in runtime error as unsupported operation exception. Now, let's look at some operations we can perform on immutable sets. These operations include union, intersection, and difference, but with a twist. Since we can modify an immutable set, any operation will return a new set without changing the original. In operating operations on immutable sets by using Java program includes the Java program demonstrates how to perform basic set operations, specifically union and intersection on two sets, set A and set B. Here's a detailed breakdown of each part of the code. Importing required classes that involves set, hash set, and collection. The set interface represents a collection that does not allow duplicate elements. Hash set, a concrete class that implements the set interface. It allows us to create sets that do not contain duplicate elements. And collections, a utility class that provides methods for common collection operations such as add all. And coming on to the main method is the entry point of the program where we define and manipulate our sets. And next part is creating and initializing sets. Creating set A and set B, we create two mutable sets set A and set B of type hash set, adding elements. Collections dot add all of set A, comma 1, 2, 3 adds elements 1, 2, and 3 to set A, and similarly set B is initialized with elements 3, 4, and 5. Now coming on to the union operation. Union operation involves creating union set. We create a new hash set called union set, initializing it with all elements from set A. Union operation. Union set dot add all of set B adds all elements from set B to union set. If an element is already present, like the number 3, it is not duplicated due to the nature of sets. It gives the output as the print. It prints the union of set A and set B as book unique elements from both sets as 1, 2, 3, 4, and 5. And coming on to the intersection operation, creating intersection set. We create a new hash set called intersection set, initializing it with elements from set A. Intersection operation involves intersection set dot retain all of set B, keeps only the elements in intersection set that are also present in set B. In this case, the number 3 is the only common element between set A and set B, and thus the output will print as 3 as the output. In summary, union means combining elements from two sets without duplicates, and intersection means finding common elements between two sets. These are the operations on immutable sets. Now, let's see the output of the given Java code. Here you can see the output of the given Java code involves union of set A and set B is printed all the elements, and intersection of set A and set B is printed only 3, which is common. Now let's discuss about the key takeaways for immutable sets. To recap, immutable sets are incredibly useful when you need to share data without risking accidental changes. Every operation returns a new set, and the original set stays unchanged. This makes them ideal for applications that require data integrity and safety in multi-threaded environments. Now let's dive into the concepts and operations of immutable maps. Now that we understand immutable sets, let's look at the immutable maps. An immutable map, similar to immutable set, is a map that cannot be altered once it's created. This means that if we want to store data in key value format without allowing modifications, immutable maps are perfect. Explanation of concepts. In Python, we use a mapping proxy type from the type module to create an immutable version of a dictionary. This is a super helpful when we want to prevent accidental changes to our data, especially when passing it around functions or across threads. Let's get to know about the immutable maps with an analogy. Think of an official printed city guide. It contains a list of landmarks and descriptions like Eiffel Tower, Paris, or Colosseum, Rome. Once printed, this guide won't change. You can look up the landmarks based on the city name, but you can't add new landmarks or remove existing ones from the printed guide. If you need to make updates, you'd have to create an entirely new edition with the changes. In the same way, an immutable map stores key value pairs like city and landmarks that can be read and referenced but cannot be modified after it's created. Let's understand immutable maps using a code. Here's a detailed explanation of the immutable map example code, which demonstrates the creation and usage of an immutable map in Java. That involves importing required classes, which includes collections. The utility class provides static methods for creating unmodifiable collections, including unmodifiable map, which we use to create an immutable map. And the second one is hash map. This class implements the map interface, allowing us to create a mutable key value where each key is unique. And the map interface represents a collection of key value pairs. And next, coming on to the main method. The main method is the entry point for the program where we create a mutable map, make it immutable, and test immutability. And the next part of the code is creating a mutable map that involves creating mutable map. We create a mutable hash map called mutable map. And the next part of the code is adding key value pairs. Using put, we add two entries key 1 value 1 and key 2 value 2. This map can be freely modified, allowing us to add or remove elements. And next part is creating an immutable map that involves making an immutable. By passing mutable map to collections.unmodifiable map of mutable map, we create an immutable map we called immutable map. Effect. Immutable map cannot be changed. Any attempt to add, remove, or update will through an unsupported operation exception. If mutable map is modified after creating immutable map, these changes will reflect in immutable map as well. Since immutable map is just an unmodifiable meaning of mutable map, to avoid this, use a separate immutable map library or make a deep copy before applying unmodifiable map. Next is printing the immutable map. Or displays the content of immutable map which are the same as mutable map at the time of creation. The output will be key1 equal to value 1 and key2 equal to value 2. And attempting to modify the immutable map which is commented out, which line is commented out, attempting to modify the immutable map would throw an unsupported operation exception because immutable map does not allow modifications. This program shows how to create a mutable map, convert it to an immutable map using collections.onModify. The output of the code will be as key1 equal to value 1 and key2 equal to value as immutable map. When we decomment the line, it will throw an unsupported operation exception as you can see here. This is unsupported operation and exception because immutable map does not allow modifications. Now, let's look at the operations on immutable map. Since Java's unmodifiable maps does not allow changes, operations like adding or removing keys will create a new map, leaving the original immutable map unchanged. The Java code demonstrates the concept of creating and working with immutable maps using the collections.unmodifiable map method. Here's a detailed breakdown of the code. The Java program imports collections, hashmap, and map from the Java standard library. Hashmap is a part of the java.util package and is used to store key value pairs. Collections is used for various utility functions for collections, including making collections immutable. Class declaration. The class immutable map operations contains the main method which serves as the entry point for the program. Code breakdown involves creating a mutable map. A hash map named map A is created which can hold string keys and values. Two entries are added to map A, key 1 with value of value 1 and key 2 with a value of value 2 is added to map A, making the map immutable. Creating an immutable map, the collections.unmodifiable map method is called with map A as an argument. This method returns an unmodifiable view of the specific map. Immutable map A now holds a reference to this unmodifiable map, meaning any attempt to modify immutable map A will throw an unsupported operation exception. Now, getting into the next part of the code, accessing values in immutable map. Retrieving a value. This code retrieves the value associated with key 1 from immutable map A using the get method. It prints value for key 1 value 1, creating a new map with additional entries. Cloning the immutable map. A new hash map B is created by copying all entries from immutable map A. This makes map B a mutable copy of original immutable map. Adding new entries. A new key value pair key 3 with value of value 3 is added to map B, creating another immutable map. Immutable map B is created by passing map B to collections.unmodifiable map, making it immutable as well. Printing the new immutable map. Outputting the new immutable map involves this program prints the contents of immutable map B, which now includes new entry, new new immutable map with additional key 1 value 1 and key 2 value 2, key 3 value 3. Key concepts explained are immutability, creating new maps, and unmodifiable views. Conclusion is this code snippet effectively demonstrates how to create immutable maps in Java, along with how to work around the limitations of immutability by creating new maps based on existing ones. Let's run the program and see the output. As you can see, the output is printed as value for key 1 is value 1 and new map with attribute key 1 key 1 value 1 and key 2 value 2 and key 3 value 3 is printed. These are the operations that we can perform on immutable maps. Key takeaways for immutable maps. Immutable maps are an excellent choice when we want to store and access key value pairs without allowing changes. This makes data handling more predictable and safe from unexpected modifications. Let's compare mutable versus immutable. Now let's quickly compare mutable and immutable sets and maps. The key difference is that mutable versions can be changed after creation while immutable ones cannot. This trade-off has advantages and disadvantages. Comparison points are Immutable structures allow flexibility but carry risks of accidental changes, whereas immutable structures offer stability and are ideal for concurrent applications. When to use immutable structures? Immutable structures are particularly useful in functional programming and multi-threaded environments where data integrity and predictability are essential. Let's quickly compare immutable set and immutable map. Immutable set is a fixed collection of unique elements that cannot be changed after creation, while immutable map is a fixed collection of key value pairs that cannot be changed after creation. Structure of immutable set stores only values with no associated keys. Stores data as key value pairs where each key is unique is immutable map. Immutable set is ideal for storing a collection of unique items like tags or categories where modifications are non-linear. Immutable maps are useful for storing configurations or settings that shouldn't be modified, such as country to capital mappings. Immutable set creation involves collections dot unmodifiable set, and immutable map creation involves collection dot unmodifiable set, same as immutable set. No modifications are allowed in immutable set and immutable map. Common operations in immutable set are union, intersection, and difference resulting in usage. Common operations in immutable map are key-based access and iteration cannot modify, add keys or values. Performance can be faster to access in multi-threaded construct due to immutability in immutable set, whereas immutable maps are safe for multi-threaded reads and often used for data consistency. When benefits of immutable set are prevents accidental changes, provides data safety useful in concurrent applications, whereas immutable map ensures consistency in key value relationships, prevents unintended modifications. Common applications of immutable sets are used in catching sets of constants or thread-safe read-only collections. Immutable maps are used in configurations, read-only dictionaries, and mapping for constant data. Let's look at the practical use case and summary. To bring this all together, let's consider a practical example. Imagine a large e-commerce applications where product data is constantly shared across different parts of the system. If any part accidentally modifies the shared data, it could lead to incorrect information. Using immutable sets and maps for this data can ensure that no part of system unintentionally changes the data, keeping it constant and reliable. To sum up, we covered immutable sets and maps, understanding what they are, how to use them, and why they are beneficial. Immutable sets and maps offer a way to protect your data, especially when working with multi-threaded applications or functional programming. And this is the this is about immutable sets and immutable maps. Thanks for watching. I hope this video gave you a clear understanding of immutable sets and immutable maps. Don't forget to like and subscribe if you found this helpful, and drop any questions you have in the comments below. Until next time, keep learning and keep coding. Thank you.